Next up, we are going to have the youngest member of our research team, Yucheng Jiang, and he is a 0th year PhD student because he just got admitted into the PhD program. He was a master's student while he was doing this work.
So thanks, Sina, for the comprehensive tutorial on how to make the knowledge accessible and make very trustable, grounded chatbots in answering people's questions. And let's ponder for a minute and think about, based on all the things that Sina have presented, are humans' information needs satisfied for any scenario? Probably not. In the taxonomy of the human's information need, we have different levels from being able to access the knowledge to, that means being able to access the knowledge in either digital form or in their original form, to be able to retrieve the information you want and to have fast question answering. And the next level is knowledge curation, which means that there's no single short answer that can answer your question. You have to find, to organize, and to present the valuable information of your interest. And there's even another level called the knowledge discovery, to discover previously non-existent information that we have no access to right now. And in this tutorial, I'm going to talk about two works in our lab that covers the knowledge curation part, which is to find, to organize, and to present valuable information of interest. Knowledge curation are focused on complex information topics that you can take some example here. They can be answered by a short question. You need to do research to collect sources from various sites and to pick out valuable things from them and to synthesize them in a valuable way. And throughout this tutorial, I'm going to use the 2024 US presidential election as a topic to explore. Think about what you want to do, if you are investigative journalist, or you want to write a 10-page kind of analysis on this topic. You usually would do I go to Google to search it, and basically I search, click, read, and I refine my search query and then read, and at the end I collect a bunch of interesting websites and sources, right? This process is kind of very much so much things to read and may introduce the echo chamber issue, which usually you search within the domain where you know that I don't know. And with the development of large language models, it comes now with the AI-powered search engine, where you ask a question, it returns back a synthesized answer that summarizes top search results on the search engine. However, this type of synthesized answer lacks the breadth and depth. It's a very quick and short answer to your question that covers basic facts like when, who, what, why, and how. It doesn't cover interest in different aspects. It doesn't go deep into this topic. And Wikipedia is a special kinds of resources with the reports that covers good, have a good comprehensive coverage. It's organized, it's reliable, and it's verifiable with cited sources. However, it takes a lot of people's time and efforts in order to write a Wikipedia article. When you search in the Wikipedia, and many of the topics of your interest may not be available there. And it takes, some of the most famous Wikipedia articles takes more than 1,000 editors to edit more than 10,000 times. So how can we kind of create Wikipedia-like article for everyone that is accessible and fast to use? And writing Wikipedia article is not an easy job, because collecting references requires literature research, which is non-trivial. And how to organize all the information into a report with hierarchical sections, paragraphs is also non-trivial. However, this kind of Wikipedia-like report is getting popular in the last 6 or 7 months. It's called deep research. It's emerged in the academia and also in commercial products. The format is like it generates a long synthesized report with citations, and is used for academic research, for market analysis, for investigative journalism, etc. And in this tutorial, I'm going to cover two applications in our lab that lies in these lines of research, which is Storm and CoStorm. We launched Storm in, the paper was submitted in December 2023, and the website was available to the people in the world since May in 2024. Since we launched, we see exponential growth of the users, and now we are very happy to have 500,000 users try this Storm and CoStorm and leave us very valuable feedback to guide our research. And our goal is to make the technology accessible, to make the knowledge available for all the people in the world. And we have been very happy to see more than 224 countries and regions in the world that users have been using Storm and CoStorm for. So let's dive into Storm first. Storm is about writing Wikipedia articles from scratch. So when we think about how to write a full-length article from scratch, what do we usually do? We probably first do some research and to draft out the outline, and then we jump into the final writing. You don't usually start from the first line of your report and write all the way to the last, right? So the first stage, we call it pre-writing, which you take a topic, you go online or go to external sources, or even talk to people to collect valuable resources, and then to organize all your thoughts or your valuable information into an outline, and then use these two sets of information to guide you to write the final report. And how to collect the good references? Usually we do question asking. We either ask the website or we ask actual people with expertise. And when you, let's say you're an investigative journalist and you have a topic and you have an expert interview, you usually do multi-rounds of conversations and go in depth with different people and different experts. And Storm kind of simulate this process. Let's do an animation of how this whole process goes. You start with the topic of interest. Then you kind of identify different perspectives of interest. For example, in the US presidential election, you might be interested to talk to different experts in different domains, like you want to talk to political analysts, you want to talk to campaign strategists, etc. And imagine you have access, you are being able to talk to experts on the right, and you are the Wikipedia writer on the left. You would do multi-rounds of conversation with each expert to get valuable insights. So we first ask questions from the writer to the experts. The experts will search for valuable information to evaluate the sources, and then come back with the synthesized answer that matters. After multiple rounds of conversations with multiple experts, all the conversation will be synthesized together in order to come up with the outline for your final report writing. And at the end, you synthesize all the information collected during this conversation with multiple experts and the outline you generated to populate and synthesize the final report. And we do extensive evaluation on Storm, both on automatic evaluation, small-scale human study with experienced Wikipedia editors, and evaluate with the people in the wild. So we compare Storm with 3 baselines. One is you directly generate a report from scratch, you just ask language model, give me an article on US presidential election. The second is RAG. You ask questions to the RAG system and use the conversation with the RAG system to generate an outline and then generate the final report. Beyond that, after you have an outline, maybe we can make RAG even stronger, which is outline-driven RAG. After you come up with the outline with the RAG, you do additional search in each section of the report to gather more information for that section, and then do another round of polishing. And in order to study Storm, we construct fresh Wiki datasets. which we collect Wikipedia topics that are created after the training cutoff of the language model we use for experiment. So the topics for the article is not being trained in the large language model. And we only keep Wikipedia articles written by human that is of good quality with rating B and above. This is the rating given by the Wikipedia community. And we only keep the topics with human-written articles that have hierarchical sections. So we have kind of roughly comparable storm-generated article and human-written article by Wikipedia editors. For automatic evaluation, we kind of evaluate both on outline quality of the report and the report quality itself. For outline quality, we kind of compare the section similarity of the storm article and the human-written article, how similar are the outline structure, and how similar are the named entities mentioned in this article. And in the report quality, we first do the automatic evaluation using language model as judge, and then we verify this result with experienced Wikipedia editors on the interest level, the organization of the report, the relevance, and the coverage of the report. Compared to all the baselines, Storm consistently outperform all the baselines and with ablations, where we do not do the outline generation, we directly jump into the final report writing. We see that Storm outperforms all of them. And beyond automatic evaluation, because like language model as judge, it's not that quite convincing, it's not quite consistent. You may argue like it's not consistent with human judgment. So we actually have 10 experienced Wikipedia editors, which have more than 1 year of experience and have been made more than 500 edits in the Wikipedia community to help us verify whether Storm does a good job to have a first version of the Wikipedia-like article in order to jumpstart people's research. So the outline-driven RAG was the strongest baseline, and we asked the Wikipedia editors to compare the outline-driven RAG with the Storm. And Storm outperforms across all dimensions with the strongest baseline in interest level, organization, relevance, and coverage of the report. And it's interesting to see that all of these Wikipedia editors are interested in Storm, and we think like Storm is actually useful for their pre-writing. Like it's actually for them to collect good set of resources and to jumpstart their writing or the research in the future. And since the launch of Storm on the website, we have like more than 500,000 users, and we're curious like why they use Storm. So we deliberately ask user, what's your purpose of like using Storm on each topic they write? And we find like people are using Storm to research, to study, and to analyze, and to jumpstart their thinking process. And users leave so much feedback on Storm websites. Like some of them are positive, like it's the first time they've been able to use one of these agents back in 2024, like June-ish. And it's very useful at the beginning of the research. It lowers the barrier to entry to further research, and we make it open source so people can customize Storm as they need. However, from all those positive feedback, we also receive a lot of feature requests from the users. And one of the most interesting one we see is that it would be great to provide some interactive capabilities, like take the user's new idea into the report generation. As you can see, like Storm basically takes your topic in and generates you a report, and that is the end of story. But sometimes that is just the beginning of your research. Your idea evolves, you want to talk to more perspectives, and your thoughts evolves. And that leads us to the second work, co-Storm, which is collaborative Storm, which is engaged human learning through participation in language model agent conversations. So co-Storm has two design philosophies. The first one is that users can choose to steer the focus of the knowledge curation throughout the process. And second, the user can sit back and listen to diverse perspectives that facilitate exploration of unknown unknowns and to explore the serendipitous finding of the user. Say, you find something that you are never think about in that direction. So we kind of adopt this design philosophy to kind of design a personalized roundtable conversations where each user is being able to sit in a virtual roundtable and being able to listen and talk to a group of agents with different expertise and different background. For example, in this topic, you're the user sit here, and we have a mysterious agent I'll talk about later. And you're sit with like 6 different experts with different backgrounds. And in this process, you can basically choose whether you want to sit back and listen or choose when you want to engage. And this is the input optional design of the CoStorm, where the user can choose to observe by watching agents talking to each other. This actually facilitates the serendipitous finding, to know unknown unknowns, to think about like what the things you never thought about before. And when you have something in your mind and you want those experts talking in that direction, you can actually actively participate in by speaking and steer the conversation. However, with this setup, you may think like, what if the user just sit back and listen to this group of agents talking, and what would happen? It actually like those agents will bring the topic into a very long tail, very niche discussion that focus on one point and laser focus on that. And that is like not quite interesting to some extent because I'm just researching this topic and I want to hear different perspectives, and what would incite me more could be something else. And imagine when you are researching the topic online, you may search online and you may find some link that is not directly relevant to your initial search query, but you think, okay, that is interesting. I'm definitely go back to that later. So there's another agent, mysterious agent, called the moderator. The moderator will ask thought-provoking questions in this process by taking inspirations from the knowledge collected throughout this conversation process. Because each agent in this conversation is grounded on external sources, and they will search in each turn and bring back so many information. But not all of them are used during the conversation, and some of them are missed in the previous discussion. And the moderator kind of pick them up and say, okay, now we may be interested to explore that direction. How about let's talk to that. So the moderator role actually facilitates the serendipitous finding that surprised the user, that the user never think about. So now let's dive into the CoStorm evaluation. Same with Storm, we do extensive study with automatic evaluation, small-scale user study, and in the wild, large-scale study as well. So we compare with three baselines. The first is reg chatbot, just like ChatGPT or something. When you have a topic to explore, you chat with this language model chatbot that have access to external knowledge, like search online. The second is that Storm and QA, which basically you have a comprehensive report or the deep research, and after the report comes out, you do the question answering and hope your new questions can be integrated into Storm or the report. And third baseline is what everyone is doing, like using the search engine only. And to study this, we construct wild-seek dataset, which consists of 100 complex information-seeking topics from Storm by the real users across 24 different domains, including chemistry, biology, computer science, finance, gaming, and healthcare. So for automatic evaluation, we evaluate the whole process by focusing on both conversation process and the final report. For the conversation, we further break down into the question asking turns and question answering turns because they have different focus. For question answering turns, we focus on their consistency, their engagement, the number of unique sources which contribute to the information diversity. Where question asking turns, we evaluate on the question novelty, whether the question is of user's interest, and whether it has no repetition to the whole process in the conversation. And for the final report, we evaluate on the relevance, breadth, depth, novelty, and information density. And for evaluation, like automatic evaluation, we compare CoStorm with React Chatbot and Storm and with QAs. And CoStorm outperform the two baselines for the final report quality on all dimensions. And additionally, we evaluate the conversation process. We're like on question answering turns, like whether so the question answering turns brings up like new information in, right? So we evaluate on the consistency, engagement, and information diversity in that perspective. And CoStorm outperforms both baseline as well. And you may wonder, like in this whole design, we consider there are multiple experts, there are moderators. Are they actually working, or they just some of them are contribute negatively to the whole process? So we do ablation studies. One ablation is that we do not have multiple experts. There is just single one experts. And one ablation is there's no moderator in this process that do not ask thought-provoking questions. And we see the novelty, the alignment with the user's interest, and the no repetition drops significantly without those two roles. So we can see that the different perspectives and the moderator holistically contribute to the effectiveness of CoStorm. And we can see that having just one expert and one moderator can already provide the most of the benefits, so the users can have their choice of how many experts they want to speak to. And for user study, we have 20 users in the wild that have different age groups and different education background to evaluate CoStorm on different topics of interest. We ask them to give the score of the relevance, breadth, depth, and serendipity throughout this process, give the rating on the both conversation process and on the final report generation. We compare CoStorm with search engine, where the user gives the similar articles in the same domain, but slightly different topics to explore on CoStorm versus search engine as the first group of 10 users, and second group of 10 users compare CoStorm with React Chatbot. And we ask them to give pairwise comparison and give ratings on different dimensions. And we see that CoStorm outperforms both baselines across all dimensions. Additionally, we ask the users to give like pairwise preference on CoStorm and search engine and React Chatbot of like which one gives you less effort, which one gives you feel more engagement, and does it kind of address echo chamber issue, whether it brings you serendipitous finding, brings up topics you never thought about, and the overall experience as a whole. Most majority of the users agree that CoStorm is better than a search engine and CoStorm is better than React Chatbot. The evaluators comment that CoStorm brings up topics that they may not even think of, and CoStorm is much less mentally taxing for the users to use. So we have Storm and CoStorm both open source and released in the GitHub. And both Storm and CoStorm can be supplied with different language model providers that is compatible with Light LLM, which supports many providers, including the GPT family, Gemini family, DeepSeek, Cloud, Llama, etc. And the search sources can be supplied with different search engines like Bing Search, Google Search, Azure AI, or your private database that is computed into a vector database, so that the whole discussion can be grounded on your private corpus. So with that, feel free to try Storm online and scan this QR code and this link, and we can discuss more during the break. And in the next tutorial, George will give the tutorial on how to incorporate structured data, since like Sina's work and our work now grounded on the free text, and how to incorporate the structured data and unstructured data together. George will give an awesome tutorial later. Thank you.
Because we didn't have time for questions, and there are various people who have come up, we're just going to do some Q&A right now for people who are interested, so everybody can hear the answers instead of just, each one of you talking to either Sina or Yucheng. Okay? So let's start with Sina's answer to Sam, right? Sam's question.
Yeah, so just to repeat the question, Sam from Washington Post asked about the details of the fine-tuning step in WikiChat.
The mic. I think you have taller.
Yeah, so the question was about the details of fine-tuning WikiChat from an LLM, let's say a large LLM to a smaller local LLM, in that case Llama. So the data is automatically generated, so there is no human annotation involved. The size of the data set that we actually used was, I think, 10,000 conversations in total. 10,000 conversation turns in total, so multiple turns per conversation. The key part was we had to make sure that in our generated data, we have a diverse set of topics. So it was important that we have, tail topics, head topics, and recent topics, so that the model learns how to behave in these corner cases. Maybe the relevant information is smaller or larger, and the topics are different. We only tried full fine-tuning, but that was, a few hours on a GPU, so we didn't really look into more efficient fine-tuning methods.
And then, given the source code, it's open source code,
yes.
So that if you want to fine-tune with our context more, is it easily kind of doable, kind of piece component-wise?
I'd like to think so, but
Okay.
yeah, I will be happy to hear your feedback if you have any questions or any comments.
Thank you. Great work. Thanks a lot.
Okay, thank you.
Hi, I've got a question for you both. I'm Subbu Vincent. I direct media ethics at Santa Clara University. I have a use case question. So can this system, either the search Genie, either the Genie, or even the co-storm approach, the mixture of experts thing, can it be used to discover what perspectives are not there in a corpus? So let's say I give a corpus of 100 news articles that was on Oppenheimer's discussion, all the discussion that happened in 2023 on Oppenheimer. And I know for a fact that Native American communities had a specific take on that film, and it came out in a couple of stories, very few stories, because it's already underrepresented. But it's there in the news sources. Now, because I'm in research, I happen to know. But if I'm posting a bunch into, if I upload that in your system and I ask what are the actual perspectives, you will get the perspectives from India, from Japan, from the US, from the scientific community, from the film critics community, and so on. But the indigenous American perspective is not there. Is it a good use case to ask the LLMs to identify those perspectives that are missing, or find where they are represented and find the actual citations from them? That's one use case.
Yeah, so there are a few different ways I think about it. So one is if you specifically ask for those, you happen to know that there's that interesting subtopic, and you can ask it directly, and the assistants will answer you. But I think your question is probably more towards like, if I don't know the specifics and I just want to discover things. Because of the very in your example, there is a very small number of documents in the set, let's say. I think there is a limitation of, at least for WikiChat, the retrieval part of finding those niches. Although I want to add before asking Yucheng to talk about the co-storm potentially being able to solve that. We had another project which was not published, but it was basically trying to build this hierarchy of concepts inside a given corpus. So at the highest level, you have maybe 20 high-level things, depending on the size of the corpus. But if we built this prototype where we would give the user the ability to click on subtopics and dig deeper and deeper. So for example, in the African Times case, slavery would be a top-level topic. Colonialism would be another topic. But if you dig deeper and deeper, then you could get into like very specific things of this local tribe's views and attempts at limiting the import of a certain grain, for example, right? So in that sense, LLMs, if used in that way, could potentially make things more discoverable in that sense. But I don't think WikiChat could currently surface all those small, fine-grained details. Do you want to comment on CodeStorm discovery?
I think that CodeStorm basically it's kind of a forward process, not like the backward, where you have a topic and you discuss this topic into different perspectives, and you can see through so there is an outline that summarizes all the conversations being up to the point. And you can see that whether some of them are even exist in your part of the small corpus, and if that doesn't, and if that implies a new perspective or not. I think it's your question is more about like backward, given a set of.
So it actually applies to CoreStorm because if you look at your expert categorization, so let's take the US presidential election.
Yeah.
About 70 million people did not vote. 75 million people voted for one candidate, 76 million people voted for another candidate, but the turnout wasn't really as high as it actually could have been. And one of the known factors is that lower income people, they vote at much lower turnouts. And that part is rarely discussed in the American, most people speak about Democrats, Republicans, but they don't talk about the lower turnout. So if that was a research article in CoStorm, how would I simulate an expert who is talking about an issue that is already absent in the actual discussion? So that's another perspectivization issue. So that's the part I don't understand. Are we generating the expert categories, or should we say there should be a community voice that actually represents people who are not in the discourse? That's not clear.
Yeah, I think so CodeStorm basically is grounded on what's available there. It's already what's there. But what is missing from what other people are writing is kind of discovering the new insights from the data available. Suppose you have a database or some kind of data sources that nobody writes about. How could you dig up new insights from the database or the data sources that you can talk about? And that is exactly the tutorial that George will give next.
Thanks, guys. Very interesting. My question is for Yucheng. What if I wanted to specifically select the experts that were acting for me as an agent? Does the system automatically generate it, and am I able to tweak it or even specifically identify, I want this person's type of perspective?
Good question. So in CodeStorm, it's a dynamic list of experts. The moderator will choose what are most appropriate experts to discuss given current workflow of the discussion. Though customization of you want to talk to specific experts and you want to only select a group of experts to speak is also customizable through code. And we will work on the customization on the UI website later.
Awesome. Thanks, guys.
Hello, Yucheng. Hi, Sina. Lovely to see you.
Yeah.
I have a quick question about WikiChat, I think, mainly, which is, Sina, what is your sense of the impact that the reasoning models now are having on factual accuracy? Is it higher, or is it basically the same as GPT-4?
So, yeah, I mean, that's a good question. We haven't run the same exact experiments, but the thing that makes it a bit difficult to discern the difference is that it seems like the reasoning models are specifically trained on to be good at different tasks, and that's just judging by the fact that usually companies announce their programming or math capabilities instead of necessarily chat or question answering capabilities. I think, let's say specifically O3 Mini is a slightly worse on factuality from what I've seen than GPT-4o. But the general trend stays the same. So if you use them as a source of knowledge, they're going to have the same pattern of popular knowledge is probably fine, then you get to tail and recent knowledge, and they will fail, even the reasoning models. This comes down to the fact that basically they don't have enough power or even size to memorize every detail of the training corpus, even if the training process was somehow would make that possible. It's just that they don't have enough expressive power to store terabytes of information. if you're asking about the use of reasoning models as part of a bigger system like WikiChat, I think they do help in specific cases. So there are things about reasoning about the relation of different events, let's say. So you want to ask WikiChat about, tell me about the timeline of events in Ukraine. And there are a lot of different things happening, and you have to be able to figure out that this thing happened before that, even if it's not explicitly clear from the context. And then being able to put that into a narrative. And sometimes I would say if it's a very tricky fact-checking part in the fact-checking, so it's if there is any subtlety in reasoning for the fact-checking part, that could help. Yeah, the other parts are probably the same trends hold.
Thank you very much.
Okay.
Hi, this question is also for Sina. It's about the chat interfaces and in particular how you evaluate them. So in our work, we found that a lot of the data sets for evaluating these kind of chat-based interfaces are very different from the kinds of questions people naturally ask. So our users will ask questions with bad assumptions or questions that don't have an answer or the question that won't appear in the sources. I'm wondering if you have, I know you spoke briefly about how you did some automatic evaluations and things like that, but do you have any sense of how we can improve in this, how we can evaluate their accuracy in those kinds of domains?
Yeah, that is a challenge, even though I think more recently there are some like adversarial data sets or more larger scale data sets just published from academic sources as well. So those might be interesting to look into. In terms of how we did the evaluation, so basically we use this idea where you can use another LLM and give it instructions. So part of the evaluation on later stages was we tell the user to disagree with the chatbot, or we give the user partial information, or we give the user incorrect information on the topic, right? And these are relatively straightforward to simulate their interaction with the chatbot, and then we have to look at the transcript of these interactions. So that was one way that we could mitigate the problems there. At the end of the day, though, I think we had to do a user study. Like, it's good for iterating and maybe figuring out the development process, but at the end of the day, before you make conclusions, you have to put it in front of users.
All right, thank you.
Hey, sorry, I missed the beginning of the question, so if I ask something that you've already, sorry. First of all, that was fascinating on both counts. I honestly, knowing how hard some of these problems are, it's pretty impressive what you've achieved. And I sort of wondered about your, the text extraction element of it, right? Because that has been a, pretty difficult problem to solve overall, right? And it seems like you've made substantial progress there. So I guess two questions. One would, in the area of work where I work, we deal with government documents that were designed for people to read as printouts in developing countries rather than for long-term storage or extraction afterwards, right? So you will get like information on budgets that is a screenshot of an Excel table that's put in a PDF and so on, right? And so you can imagine how difficult that is to extract with like regular techniques. And it strikes me as some of what you're doing could be extremely helpful, right? Because you get that for a human, it's really easy to get how a table works. Trying to parse a table that is not very well, or that is too formatted, right, is quite difficult. So I'm wondering your thoughts about how that system could be repurposed for that. The other thing was that you said 50 cents per page, and that is, I guess, a worst case scenario in which you have to do 11 iterations, right? But a lot of the text, government text, may be a lot cleaner than that. It may not be good enough for a regular OCR, but do you have kind of examples of how the price drops down if you don't need to go through the iterations?
Yeah, so those are great questions. So about the price, because that has a shorter answer. So new models come out every day. So if you want to, so the estimates, for example, were for GPT-4o. But if you look at the latest Gemini 2.0 model, those are, I think, 5 times cheaper with the same quality. They're actually a bit better on vision tasks, in my experience. So that's another, a 5 times reduction in cost, like basically overnight, just because somebody released a new model. So these things change a lot. I think in simpler pages, the cost is basically determined by the amount of text in the output. So if it's a larger page, you can assume that, almost fractional. Like if it's half a page, then it's going to cost half. Yeah, so, if it's just a screenshot, probably cents, 5 cents, or, whatever the smallest cost these days.
And on the extraction of like the tables,
Yeah,
the
yeah.
design tables, because that's a huge one, right? Like there's so much data locked in these types of documents that I'm curious about how we
So-
could leverage your
Yeah, I think,
approach.
so I mentioned the Markomo corpus, which is basically large tables of ship logs in like tables of this date, this was the destination, and I think someone in the audience actually introduced us to that corpus. I don't know if it's here. But those are actually much more challenging than just extracting text from newspapers, it turns out. This requires a different set of techniques, especially if it's an irregular table. So we haven't focused specifically for those. I imagine there are, some of these ideas are applicable. But at the current stage, it's not like we can just take the system and just apply it blindly. We have to do more work on that, I think. Especially long tables, multi-page tables, or complicated tables. Simple case, probably LLMs can handle it, but we have to figure out the more complicated cases.
And at the time, you don't have any kind of area of research on those topics planned.
Not at the moment. We have been basically trying to get the historical newspaper to a high enough quality that we can just reliably use it everywhere. And those, they don't have very large tables. Yeah, but that is a very good point and a good direction for future research for us. So
Maybe
thank
something
you
to
for
connect later. Yeah. Thank you.
Yeah, yeah.